right, we're going to do problems 6 through 9 now and review day 1. First one gives us a definite integral, and we can see that we have x cubed plus 1 inside of the 1/2 here. So whenever we have a function inside of another, we need to think of a u sub. So our u here is going to be x cubed plus 1. Our du is going to be 3x squared dx. So dx will be du over 3x squared. So when we go to set this up, we're going to have the integral of u to the 1/2 times x squared times dx, which is du over 3x squared. Those x squareds are going to drop. We're going to have a 1/3 that comes out times the integral of u to the 1/2 du. Now again, when we do the u sub on a definite integral, we have to take these are x values. That was x equals 0, x equal 2, and we've got to switch them over to u values. So when x is 0, 0 cubed plus 1 means that u would equal 1. When x is 2, 2 cubed plus 1 means u would equal 9. So we end up with 1 and 9 there. Okay, and we're not going back to x. We now have an integral that we can work with, and whatever this equals, that's the answer for that one there. So we'll go ahead and integrate. This is going to integrate up to u to the 3/2 over 3/2. And we're going to do that from 1 to 9. So if we flip that, that becomes 2/3. So I'm going to go ahead and do that. And then 1/3 and 2/3 will create 2/9. All right. Now I can do the top minus bottom. This is going to be 9 to the 3/2 minus 1 to the 3/2. So this is going to give us 2/9 times 9 to the 3/2. That's square root of 9, which is 3. 3 to the 3rd power is 27. And 1 to the 3/2 is 1. So I end up with 26 here. 26 times 2 is 52 over 9. And how about that? That was option A. All right. So a little bit of work there. Just had to be careful, but it's just a u sub. Okay. The next one gives us a slope field, and it says which of the following differential equations would have made this slope field. So again, in a case like this, you may want to consider where your horizontals are. We see that we have horizontals where y equals 4. The problem is each of these have a 4 minus y part, which would give you 0 when y equals 4. So we can't knock any of those out. So probably the best thing to do is just pick a point, try it, and see what you get. So if we try 2, 2, all right, at 2, 2, we're expecting a positive slope. So if I put 2 in for x, 2 in for y, I'm going to get positive, positive. That's okay. Put 2 in for y here, 2 in for y, I get a positive. 2, 2, 2, all positives. 2 squared, 2 positive. Okay, so that didn't eliminate anything, no big deal. You could try 2 comma, say like 5, because I noticed that that one's negative. So let's see if I put 2 in for x and 5 in for y, will I get a negative? So 2, 5, that'll be negative. 5, 5, that'll be negative. 2 times 5 times 5, that'll be negative. Okay, that'll be negative 2. So again, we're not getting anywhere in this first quadrant. Maybe we should try a little different quadrant. So I'm going to head over here to negative 2, 2. And I notice that the slope line there is positive. So when I put negative 2 in for x and 2 in for y, I should get a positive answer. So negative 2, 2, that's going to give me a negative value. All right, so I can cross that one off. 2, 2, that'll give me a positive. Negative 2, 2, 2, it'll be a negative times a negative, which will be a positive. That's okay. Oh, wait a minute. Apologize. Negative 2, 2, 2. That'll actually be negative, positive, positive. That'll give me a negative here. Cross that off. 2 squared times the 2 here. That'll be positive. So we got rid of 2 from that quadrant right there. All right. So let's try one more. Let's maybe go to quadrant 3. And it looks like if we go down here to say negative 2, negative 2, we end up with a positive slope there. So if I put negative 2 in for x and negative 2 in for y, I should be able to get a positive answer. If I put negative 2 here, negative 2 there, I'm going to get a negative times positive. That's a negative. But if I put negative 2 here, square it, that's positive. times positive, and there's our choice. Okay, so it took a little bit of trying, but that's how you have to do it. And just be real careful when you're plugging it in to see what you get there. Okay. All right, our next one has a population of yeast given to us as a differentiable function, and we're told that the derivative of that, the differential equation of this, is k times y, where k is a constant. Times 0, the weight of the yeast population is 120, and it's increasing at a rate of 24. So when t equals 0, we know that the population is 120, and we know that dy dt at that moment is 24. So what we could do is test that out. Let's put 0 in for t and see which of these gives us 120. The problem is, if you put it in here, 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 and here, you get 120 for all of them. So that doesn't help us, but this probably will. Let's see which one gives us a derivative of 24 when we put t 0. So if I take the derivative of this, I get 120 times e to the 24t times the derivative of 24, which is 24. Now if I put 0 in for t, this is going to go to 1. There's no way that's going to go to just 24, so I can get rid of a. If I go to b, the derivative of that is 120 times e to the t over 5 times 1/5. 1/5 of 120 is 24. And if I were to put 0 in for t there, that would go to 1. 24 times 1 is 24. So that might work. All right, we're going to leave that one be. If I take the derivative of this, I get e to the t over 5 times 1/5. The derivative of 119 is 0. If I put 0 in here, I'm just going to get 1/5, not 24. And if I take the derivative of this, I get 24. Okay. Now, here's the deal, is that the equation says that the derivative is k times y. So it's actually an equation. It's not just 24. It's going to change as t changes. And d, the derivative is always 24 no matter what t equals. So because of that, even though I got two answers of 24, I know that we're looking for something that has a change to it, not something that's just going to be a constant 24. So our answer on that one is B. All right, and then we get to this one. This one's a little crazy. I'll admit the first time I did this one, it took me quite a bit of time to wrap my mind around it. What we can do is eliminate a couple things real quick. It says, which of the following is false? So this one says the limit of f at 1 is equal to 0, and you can see the function does look like it equals 0 at 1, so that definitely is true, which means we'll get rid of that. Limit of g at 2 does not exist, and you look at 2, we got that jump discontinuity, so for sure that's also true, so we can get rid of that. Now the other two seem true. This says the limit as x approaches 1 of f times g of x plus 1, and if you were to put 1 in there, 1 plus 1 is 2. We already said that the limit at 2 does not exist, and so it says the limit of the product does not exist. So that seems true, but then when we look here, it says, what about the limit as f of 2? F of 2 exists, and g of 1 exists. Does that exist? Well, that certainly seems to exist as well. That seems true. Then you start to really question yourself. Now, these two we feel real confident on, right? If you had to go 50-50, that's not the worst thing in the world. Here's the sneaky part. It's right here. The limit as x approaches 1 of f of x, we already know that's equal to 0. And because you're multiplying here, you would actually multiply these limits. So even though g doesn't exist, 0 times anything would be 0. So I know it seems weird, but that's why that does exist and makes that false. So nothing to get too hung up on, but that's how you do that one.